Welcome to the most pretentious talk title of the conference, Swift Platform State of the Union. I am not affiliated with Apple in any way. I have no right to use those words, but I am a software crafter. Software crafting is actually a global movement. You may or may not be aware of it. Part of my hope today is to expose you to new ideas that may be old ideas, but if they're new to you, wonderful. Software crafting at its heart is about continuous improvement. We want to keep getting better at our craft. It is an individual pursuit. It is also a team pursuit. It's not just me by myself getting better at this stuff that I do. It is us as a team working on something, learning how to deliver software better. And so that has strong overlap with another movement called Lean. That's one of the core values of Lean, is that we continuously improve. And as a movement, it is not focused on any particular language or platform. If you find a software crafting group, they will tend to say, we are platform agnostic. This is a good thing, but it's also a challenge, especially for those of us in the Apple ecosystem. It means we have to maybe pay attention to other folks and learn and struggle and read through code that the syntax looks a little odd, but that's okay. If we learn to do those things, we'll be exposed to powerful ideas. Software crafting shares quite a bit of overlap with extreme programming. They are very, very close. I would say the Venn diagram between those two is near 100%. Extreme programming is now an old but still valuable set of practices. I would boil them down to two. There are a number of practices, but I would boil them down to just two. We want fast feedback, and we want to work together. The part of extreme programming that makes it extreme is the idea that anything worth doing is worth doing continuously. It's a radical notion. For example, code reviews. Code reviews are definitely something that is worth doing. So in extreme programming, we do them continuously. We don't wait for a code review. We don't even submit a pull request. We get the code review as we work. Same, of course, well, that's a form of fast feedback. It's also a form of working together. So that pulls those two together. You're going to see these words come up a few times during this talk. And someone suggested to me that there are actually, before principles, there are values. But the principles of fast feedback and working together lead to certain set of common practices that may be uncommon to you. These practices, then we want tools to support those practices and make those practices more effective. But at its heart, it's not even focused on the tools. They are practices. But the tools are great, aren't they? I love a good set of tools. If you watch somebody, a professional builder, they're not out there with a hammer and a nail and in danger of hitting their fingers with the hammer and making many taps on the nail. No, they're taking their power tools and going poof, poof, and working very quickly. So, what I want to explore in our time together this morning is, what are the practices? What are the tools that support those practices for Swift, and where are they lacking? What inspiration can we find outside of the Apple ecosystem? And that raises a big question. SwiftUI in particular made this a big question. It was already a question of, does Apple own the entire road? But with SwiftUI, it becomes very easy to, as it were, take the Apple pill and just assume that their way is the only way, especially with SwiftUI. We have the lovely canvas with the preview. You can see how it's being laid out as you're working. It's great. So therefore, Xcode must be the tool that you use for SwiftUI. And along came this article from JetBrains. And I said, what? This puzzled me. As an AppCode user, I was not aware that they had any sort of preview system, and the answer is they don't. Or didn't. Alas, AppCode. I knew you. AppCode does not have a SwiftUI preview, so how is this possible? So I read this article and found that where Xcode creates its own sort of closed loop system, and that way, right, Apple likes to shepherd you on the entire journey. Instead, this article did an end run around that system by saying, well, what if we use AppCode, how can you use SwiftUI? You can use it by using injection 3, which does hot reloading, and see the app laid out in real time as you code in the simulator. So this is an illustration of how just because Apple says one thing doesn't mean it has to be that way, and there may be other ways that we can work, which may or may not be better, depending on your purposes, but I don't want to be locked down. In fact, who was doing Mac development before Xcode? Hey! So was I, and then Apple came out with their IDE, right? Xcode, our friend. Worked great. About 10 years ago, I started using a different IDE for Mac and iOS development. I guess it was iOS for me at that time. I started using a different IDE called AppCode, and my mind was blown. People criticize it for being uglier, and I didn't care because the tooling was so much more powerful. I thought, this is fantastic. This is the height of programming. And then I used another IDE, IntelliJ. Now, IntelliJ and AppCode are from the same maker, JetBrains. And so you would think they're roughly the same, and they're not. IntelliJ is their flagship product and is even like that much more powerful than AppCode. Again, my mind was blown. My encouragement or my story here is it's good to stretch. It's good to explore the world. It's good to meet other people. It's good to try a different language, a different IDE, be exposed to different tools because you'll be exposed to new ideas, which then hopefully we can figure out how do we take those ideas back with us to where we work. So our tour today is through these sections. I had to cut remote ensemble programming for the sake of time, and there wasn't really anything Swift specific in there, but there is coding specific stuff. If you want to talk about ensemble programming, how to do that remotely, that is mob programming, talk to me later. But let's go through these: dependency analysis, unit testing, continuous integration, test-driven development, and refactoring. These are the practices I want to focus on, and the question is, what tools do we have what tools do we not have? Starting with dependency analysis. The answer that, or the question that I want to answer is, what depends on what? I want to see it. I don't want to have to recreate it by hand. I want to see it visually. What depends on what? Most books on software design focus on the logical design aspects, classes and functions and how they work, architecture, as you will. This is the rare book that focuses instead on physical design, meaning how do we take those classes, how do we take those functions and organize them into files, into modules, into systems. So let's take a look at the physical design of part of one of my old apps, and it is quite old. You may recognize Objective-C. For those of you who have not done Objective-C, this will look a little odd to you. I'll explain. Trail.h is the header file. That is where the API goes. So the internal API, as it were. So that's the header file, trail.h. Trail.m is the implementation file. That's where the code goes. These files include each other or import each other through statements. We use import statements in Swift only for modules, but in Objective-C, we have to start at the file level, and so each implementation includes its own header. So trail.m imports trail.h. Trail.h imports activity.h because trail is a type of activity. So there's a dependency between trail.h and activity.h, and so therefore an implicit or an indirect dependency between trail.m and trail.h. This means that for compile time, we can improve this by saying, or I can make changes to activity.m and rebuild that. The other things don't have to rebuild, they just have to relink. So this is the type of idea we can explore with physical design to say, how can we optimize build time in certain ways? These ideas collapse, according to the book, into saying, just let's not talk about the files. Let's just deal with these ideas called, abstractions called components. Trail depends on activity. What this is a behavioral dependency. Even if it doesn't rebuild, certainly if the activity portion, if I change that, the behavior of activity, that affects the behavior of trails. In Objective-C, we could visualize this with a tool called obj-dep, which goes through, it didn't analyze the code at all. All it had to do is a very simple program to look at the import statements and sort of smush them together and create a graph such as this. This was the kind of monstrosity that would be revealed to you that is now hidden from us. You see all those lines going every which way, and there are blue lines in there. Those blue lines are bidirectional dependencies. Oh, A depends on B and B depends on A. That's like a double drowning. That's not great. This impacts maintenance. It impacts our ability to understand the code that we look at from a rebuilding point of view. If you touch any one file in here, you can just imagine we're pretty much going to have to rebuild everything. And even if we don't, it may have consequences elsewhere throughout this whole graph. Another problem I faced with code like this is reuse. We want to pluck one component, one file out. It has the good stuff that we want to use in another project. You can imagine, maybe you've lived through this, where you're like, I need to I need to bring this file. Oh, it imports this thing. Okay. Oh, that imports this thing. And you have to keep pulling and pulling and pulling at the thread, and before you know it, you've pulled everything in, and it's terrible. This is the kind of physical design problem that we could make clear with obfcdep, and that as far as I know, and you can point me in the right direction if I'm missing something, there is no such tool for Swift. Now, we can do this with import statements across modules. We can see which module depends on what. That we can do. But as far as what file depends on what, Now, Swift must know, and if any of you have worked inside of the Swift compiler, I haven't, it must maintain an idea of this is changed, therefore this must be rebuilt. I'd love to bring that out somehow. And I don't know how. I explored one tool that someone wrote several years ago that doesn't look like it's been updated, or it certainly didn't work for me. So no great tool to present to you here, just sort of a wish that maybe we can solve. Maybe we can solve this. That is dependency analysis. Let's move on to, if you know me, one of my absolute favorite topics, unit testing. In the larger world of unit testing, they call them XUnit for the sort of the abstract architecture that represents most unit testing frameworks. Where X is replaced by, for example, J for Java, N for .NET. So we have JUnit, NUnit, CPP unit, and so forth. What do they have? What sorts of things are available to folks outside of our little XC-test world? And what are we missing? What might be on the horizon very soon? Let's take a look. To look at this, there are two basic parts of any unit testing framework. One is the test description. That is, I need to write a test and have it be recognized as a test. The other is the test runner. You may not think about the test runner very much. You just think, I'm running the test. Well, we don't run the test. We ask the test runner to run the test, right? What things could it do? So let's start with the test description. This will be familiar to you if you've written any tests in XC-test. There are a number of rules you have to follow. And from the opening pages of my book, I lay them out. A function, in order for a function to be a test, it has to live within a subclass of XC-test case. Okay. It can't be private. It has to start with the letters T-E-S-T in the name. Otherwise, it won't be picked up. It can't take any parameters, and it has no return value. If you follow all these rules, voila, you have a test case. This is how things have been in the XUnit world in its early days. If you look at JUnit, they didn't stop there. They kept moving forward. This is an example of a test in JUnit using Kotlin. And I want to point out some things on here. First, there's no subclassing required. It's just a class living out there. There's an @test annotation, and there are other annotations, and you can stack them. For example, we could say, this is a test, but for the time being, I need to ignore it or skip it. So annotations. There is no need to start with TEST, And in fact, you could have a natural language description in Kotlin by using backticks. Ooh, I wish we could do this. And maybe some enterprising person who can get into the Swift, this would probably require change to the Swift compiler to support backticks, right? Wouldn't that be cool to be able to write a name for a test that says, it just describes the test? And a piece of baggage that we're so used to is having to type XCT assert all the time. Why can't I just say assert? And the reasons are, well, they go back to Objective-C. Back in Objective-C, we didn't have namespaces. Everything had to have 2 or 3 letter prefixes on everything we wrote. And so that dates back. It would be nice to get rid of, not have to type XCT assert all the time. So there seems to be good news right on the horizon. And I am keen to see what Apple tells us in a couple of weeks about the Swift testing framework that they announced recently. If you look at this, this is the same test. Now, there is no subclass requirement. In fact, there's not even a class. It's a struct. Oh, this is interesting. There's an @test annotation, and it can take traits, a number of arguments, such as a natural language description. Unfortunately, the function name, even though we no longer have to start it with TEST, it still has to be a Swift function name. So that's a bit of odd friction to me, but this is fabulous progress. And a simple assertion by just typing #expect. Ooh. I'm very, very excited to see where this goes. It is also open source and we can contribute to it. So maybe we can start to be part of this game with Apple. And let's see what they announce. Another part of describing test cases is how many tests do you have to write? For folks who were in my TDD workshop, we did FizzBuzz among various exercises. And in FizzBuzz, normally in XCTest, I would write a test for 1. That 1 goes to 1, and 2 goes to 2, and 3 goes to Fizz. 4 we don't need. 5 goes to Buzz. 6 goes to Fizz, and so on. It's quite a few test cases. I usually end up with twice as many lines of test code as I do production code. 2 to 1 is pretty normal for me. Outside of XCTest, they have other tools. They have the ability to write parameterized tests. In NUnit, for the last, 15 years, they've been able to add an argument to their test function and say, run this with 3, 6, and 9. These should all evaluate to Fizz. That looks like a lot easier to manage. It can even take multiple arguments. I don't necessarily recommend writing a test like this, but you can if you want to. We could code up, this is all of FizzBuzz. We could code up to say each test case specifies the input and the expected value. So you find 5 goes to Buzz and 10 goes to Buzz, and they just run through as regular arguments. It would be nice to have something like this in Swift. Here I have good news. You can write stuff like this today in XCTest by using a lovely tool by Bill Wake called EGTest. EGTest has, as you can see, a check function which takes an array of EGs, examples, and a closure. And it simply takes each element from each example and pipes it through into the closure. What Bill has done, which is really nice, is that if there's a test failure, let's say 10 fails to go to Buzz. If that fails, the highlighted line for the error will point at the example for 10 and Buzz. So super nice. Check it out. You can use this right now. But you may be saying, but John, we have Swift macros now. Couldn't we do something like this with Swift macros? Thank you to the folks who wrote this macro. It's got a little typo, but don't worry about that. Here we see at parameterize, specifying an inputs of 3, 6, and 9 that go into the test as an argument. Nice. What about Swift testing? You can see it is very, very similar, what we will be able to use very soon in Swift testing. So here I'm stoked. I'm excited. That is the test description part of the unit testing. Let's shift now over to the test runner. You may not think about a test runner very much. Test runners can do surprising things. Here's an example from, well, I think all the JetBrains IDEs support this. And that is the ability to take whatever test suite you are running, in our world, that would be the scheme, and select a button that says, rerun this automatically. So what happens is, as you type, after a certain delay, which you can specify, it'll try to rerun the test. Of course, it'll try to build, and then if the build is successful, it'll just keep running the test for you. Automatically, continuously. There's that word continuous again. I'm going to be saying that a number of times. This is extreme. This is the sort of thing that I want to try to lean into and use to keep me in line so that I can stay focused on the task. So that's one test runner thing I wish we had. Another thing that I wish we had goes back to the dependency analysis question and back to my Trails app. This is the obfc-dep output for part of my my Trails app, old Objective-C, and I've highlighted in green the tests, and you can see now what depends on what. Trail depends on activity, so if activity changes, well, that could affect everything. If trail changes, that could affect everything. But if root view cell changes, or trails root view cell changes, well, I certainly want to run the trails root view cell tests, but I no longer need to run the trail view controller tests. They will continue to be whatever they were doing before. They'll be unaffected. It would be nice if we had systems that could make this dependency graph for us, figure out what's the minimal set of tests we need to run. And the rest we trust will continue to be have the same results that they had before. Folks have this in IntelliJ. This is a test or a tool called Infinitest, which says it computes which tests need to be executed. So it does that thing, and it's also continuous. So, obviously the benefit of reducing the number of tests that you run is speed. You get the feedback faster. fast feedback. Do we have anything like this for Swift? And the answer is almost. Almost. It's great. This is Xcode selective testing. If you have your app broken up into modules, it will analyze the modules, because we can do that, and determine which tests need to run. So in this example, if we made changes to the login module, well, certainly we want to rerun the login tests. And then the login UI, well, that might have changes now, so it would rerun those tests and the main app tests, and all the others we can just say, they're fine. They're fine. I haven't used this on build server yet, but I saw in the README, it says you can set this up on your build server as well. So I'm getting ahead of myself into build server land, but check this out. My wish here is that it could be not just module minimal, but file minimal. That would be wonderful. And maybe an easier wish would be that it would be could be continuous, that it would just keep running whenever it could. Another thing that I was exposed to in the outside world with test runners is when I was working in JavaScript. Forgive me. But Jest is pretty nice. Huh? So imagine that you are working in a suite of tests and you have a failing test for whatever reason. Either it's intentional because you're doing test-driven development, or it's accidental. Either way, it has your focus. And to run the suite of tests will still take the same time, but simply by running the failing test first and putting that ahead in the line, you get the feedback faster. So it felt so good, it felt so much faster to have the failing test report back first. John's wish list continues. Finally, on the test runner wish list is something that we have in XCTest, kind of. And that is random execution order. A good test is completely isolated from other tests. And it should not matter what order you run the tests in, but if you could keep running tests in the same order, it may hide dependencies between tests. You may not know that they exist. And so a way to suss that problem out is to randomize the order. Great. And Apple announced this. I was like, yay. And I went straight up to me and Andrew Ebling walked up to the labs at WWDC and said, this is great. There's a problem. When we get a failure because of the random test order, how do we rerun that same random test order? It's been a while. I'm a little frustrated on this front because RSpec has had this for a dozen years, RSpec for Ruby testing. What they have is a test run that has a randomized test order, spits out in the test log the seed, the random seed that you can that determines the order of random numbers because they're not really random. And all you have to do then is find that in the log, say, there it is, copy that, paste it in, say, use this seed, there, it's fixed. So maybe we can add this to Swift testing. Maybe we can add this to Swift testing. We'll see. So there is our tour through unit testing. Next up, I know this is a lot of stuff, and believe me, I cut quite a bit. continuous integration. I like to work on systems that encourage small, frequent commits, because the bigger the commits are, the more is at risk. With the smaller the commits, the smaller the risk. If there's a problem, the quicker and easier it is to locate and revert. So this is a good thing, yes? We should all work like this, yes? The reality is horrible. We've all felt this. What happens here? Why are we waiting for the CI build when it worked so fast when we ran the tests ourselves? And here there are economic factors at work, not so much technical factors. Apple Silicon machines are fantastic, aren't they? It's the best thing Apple's come out with in recent years. Forgive me, Vision Pro. The local build speed is just great. And then you say, okay, I'm gonna open the PR and wait, and wait, and wait. Why the wait? Well, if you're using something like GitHub Actions, then the default test runner you have is a virtual thing on a Mac, but it's on a Mac Mini and it's on an Intel Mac Mini. And they have racks of these things because that's what they have. That's what you're gonna get, unless you pay them money, pay them more money, which is an option. And it's certainly something to look at. It's something to consider, because this is something every DevOps team obsesses over. I think every developer should obsess over, to say, I need the feedback faster. Please, please, every minute, right? We've focused on this so much. One solution is to say, well, then I get to pick the hardware. In fact, I'm going to go buy the hardware myself and get the fastest Mac I can get, and say to whatever build system is out there, this is what I want my builds to go on. Use this thing. And they will provide, of course, the tooling that you need to add to your system to do so. So this, I think every company ought to take a look at this. The savings would be enormous if you can just bring down the build times for everybody just by running on something that's fast. But even with this, we are still waiting. And here I want to ask a question. Why are we waiting at all? I don't think this was part of continuous integration. Continuous integration, the idea as a tool, we say CI, and we usually mean the build server. But I want to take a step back and say, but what is CI as a practice? It is a practice and not a tool. What is it actually? There may be some surprises for you in here. So let's see how Martin Fowler defines continuous integration. Here are some, along the bottom, you see the components. We have our local environment where we are working together on a computer, not just a single person. Sorry, I had to work in ensemble or mob programming somewhere in my talk. So that's us working together. There's the central repo, and there's the rest of our teammates also working together in little groups. How does this work? How does continuous integration actually work? It works the same way at the start as you would expect. We have to pull. We're ready to start work. First thing we do is we pull from the central repo, update our stuff, we're ready to go. And then we make the changes that we want to make until we're happy. Everything is building, all the tests are green. But meanwhile, our colleagues have been submitting their changes, right? So far, this is familiar. This is the part where things change in continuous integration from how it's normally done for most groups today. There have been changes in the repo. We're ready to submit our changes. What comes next? The first thing we do is say, well, we've got to get up to date. So we pull again, rerun the tests, and make sure they're green. They run quickly, and we push to main. At that point, the build server kicks off. It does its usual thing. But while it's going, our teammates can take our changes. We tested them. We know that they work. At least they will work. We have high confidence that they will work on the remote server. Does that fail sometimes? Yes, it does fail sometimes, because it works on my machine. But this optimizes for the success path. And eventually we get a notification back saying all is well, or all isn't well. If all isn't well, we hear about it in one of two ways. Usually our teammates will tell us before the build system does. Say, hey, and they can quickly look and see which group did this come from. Whoa, you guys, you broke the build. And at that point, everyone stop. Everyone stop, fix it. It works well. But this system of not waiting for a build server and instead as trusting each other to run the tests locally and then pushing straight to main is called trunk-based development by many people, but it is at the heart of continuous integration. To get from wherever you are to this, I wouldn't just jump into this. It would be a journey, but we can talk offline about how could you start to move in this direction and what the benefits would be. So that's what I wanted to share about continuous integration. Let's talk about TDD. I love TDD. And there are a number of patterns in test-driven development. One is obvious. The test comes first. Okay. One is not so obvious, and it's spelled right out in Kent's book, but I didn't read that until recently. And I wish I had, because I wish I'd learned much earlier in my TDD journey to start from the assert first and work backwards. Because the whole question is, how do I know how to verify the outcome? If you don't know how to verify the outcome, then you can't even really start. But if you have an idea of how to verify the outcome, you can then work backwards and say, how do we get there? In this example, so you have an assertion. It's talking to things that maybe don't even exist yet. So in this example, and I'm going to play a little video for you, and let's make sure that's up. There's an assertion with an XML builder, and we want to test that the XML builder spits out open-close quiz tags, all right? And we're working backwards to frame first. This is one of the patterns we teach, to frame up just enough so that the test fails successfully. Here we go. The XML builder doesn't even exist, so we need to create it locally. We're going to create it by initializing an X. Are you able to hear that? Okay, sorry, let me try it again. The XML builder doesn't even exist, so we need to create it locally. We're going to create it by initializing an XML builder, which also doesn't exist. We're creating the dependencies that XCT_assert equal needs. This initializer will take a quiz string, and we can ask ourselves, should this have an argument label? I think it makes sense to call this root name, so let's do that. And now it's time to create the XML builder type, so we'll use the IDE to do that. We'll create it in a new file, and we can choose the kind of type. Let's make this a class. We don't want this to go into the test folder. We want it in the production code, and we make sure the target is correct. There's the class and the initializer. The IDE is asking us to confirm the argument type, and string is fine, and we won't put anything in the body yet. Now back in the test code, it's time for us to create the toXML method. We'll say create that. The return type will be string. And for the body, instead of this fatal error, let's just return an empty string for now. Now we can run the test. And it fails because it returns an empty string instead of quiz. That is, instead of open and close quiz tags. And that's fine. We wanted to get to red at this point. And now we have a compiling test that fails, so we're in red. We can next think about how we make this test pass. How do we get to green? So then we continue with the rest of test-driven development, but this is an example, quick example of how TDD works well when there is tooling to support the idea that the caller creates things that it needs. For example, you click on an undefined type and decide, basically ask, make this type, whatever it is, without leaving the call site. Or there's a method that doesn't exist, and you click on it and you say, create that for me, the skeleton of it. It makes test-driven development much faster, much smoother. It lets you stay focused on the caller's point of view, which is really one of the important elements of TDD, is that it is a design practice. Now, this is something that the Eclipse IDE had over 20 years ago now. So honestly, I don't expect to see it in Xcode anytime soon. Does that mean we're stuck? Well, let's move on. Let's talk about refactoring, and are we stuck? Have any of you been frustrated by Xcode's automated refactoring support? Yeah. You don't know what I'm talking about. It doesn't exist. Now, of course, it's there. It's frustrating. But I don't think that, I don't think we're out of options. Let me show you. First, let's get into how to refactor, how to use Xcode's automated refactoring in the first place. Let's say we want to rename this method. And so what I do is context, click on it, brings up the context menu, scroll down, overshoot, move the cursor very carefully over without leaving the line. It's a lot of action, and it's a lot of thinking to get there. It's rather slow and cumbersome, and it is especially frustrating to do that and find out that the option is grayed out, right? What this does is it trains us to stop using it, which is a shame, because even though Xcode's automated refactoring is on the weaker side, it's still there and it is still more useful and quicker than doing it by hand when it works. So I recommend setting up key bindings. These are the ones I like to use. Control Command N, N for name. So rename is what I like, how I like to think of that. That does have a conflict with an existing key binding, but I don't make new workspaces nearly as much as I rename things, so I kick that out, replace it. Control Command M for method. This is the key one, is that it often doesn't work, but sometimes it does. And so rather than go through all those steps to discover, oh, it doesn't work, at least now you can do it in one shot and know very quickly whether it will succeed or not. And by doing that, then I encourage you, try it more often. Try to use this more often. V for variable. You may wonder why I don't have this assigned to extract to variable. And that's because extract to variable extracts a single value. But often that value is repeated. And so Xcode has this other thing called extract all occurrences, which is usually what I want. Again, it sometimes, often, doesn't work, but sometimes it does. So with one keystroke, I can know. And one more for a bonus, there is a delete line command that we don't have access to. It's not in the menus. It's probably in there for Vim support. But hey, assign something to it. I like command delete. It's quicker than selecting. It's quicker than going triple clicking. That's for bonus. So automate refactoring, not such a great story in Xcode. And that's the list comparing Xcode and AppCode. And you may think, oh, I thought AppCode had a lot more refactorings. It doesn't look like that much more. But first, in AppCode, they work, which is a bonus. But also, you see there's various extract closure is nice. But extract variable and extract method have an opposite action of inlining. Taking a method, for example, that's out there and saying, I want that method body in here directly. I don't want to call it, I want the code in here. That's called inlining. And so one of the great things about refactoring, one of Kent Beck's definitions of refactoring, is that it's an action that you can take that you can also undo. Without just undoing, you reverse it. Another one that's one of my favorites is change signature. That's the ability to say, I want to reorder the parameters, or I want to add a parameter, or remove one, and it will update all the callers. Much, much easier. So that's Swift, and you may think, oh, okay, that looks pretty powerful, but if you could have seen the glory days of working in Objective-C, how many more possibilities AppCode provided on top of those. And then on top of those, they have intentions, which are different ways of changing the code. For example, taking a trailing closure and saying, convert it to an argument, or go the other way. Super handy. I'm not expecting you to read all this. Do pay attention to De Morgan's law for a second. That's right under convert to trailing closure. De Morgan's law is Boolean math. It's just a proof, a simple thing that says those two expressions are equivalent. It's a good way, a good tool for simplifying logic often. You can try things. Remember that for a second, because I want to show you now Swift in something else. Now this is, for those of you who have done server side on a on Linux or whatever, this is like, oh yeah, But for the rest of us who haven't, you may be wondering, what the heck is this IDE? This is Visual Studio Code. VS Code kind of gets a bad rap. I've heard people criticize it and say, it's not really an IDE. It's just sort of an empty shell of an IDE. And the answer is, that's true on purpose. By design, it doesn't know directly about a particular language. That's VS Code in the blue icon there. They want it to support multiple languages, and so what Microsoft did was they came up with this abstraction in between called the LSP, the Language Server Protocol, and it takes care of highlighting, it takes care of formatting, completion, refactoring. So for Swift, there's an official Visual Studio Code extension that uses, as you see right there, the source kit LSP. That's that magical middle layer. Interesting. It gets more interesting because just a few weeks ago, Codify posted this. It was an announcement that the LSP was getting more refactorings, and I love this statement. If you have a favorite refactoring action you want LSP to support, you can build it entirely in Swift and turn it around as fast as you can put up a PR. I'm like, ooh, I like the sound of that. When I went looking at this pull request, whoops, it's kind of hard to read, but there, as one of the examples at the very bottom is, De Morgan's Law. Look at that. That's the kind of transformation I want to tell the IDE to do without having to think about it. Think from a higher level and say, apply De Morgan's Law. Another one that Codify posted in a video was convert JSON into a codable struct. And this goes so quickly, I have it looping. See that? You paste JSON, select the light bulb action and say, convert it to a codable struct. And it just does it. And I'm like, ooh, this is the kind of tooling I want. This is the kind of tooling where we can specify not the nitty-gritty details, but the larger intentions. But back to present day. What do we do when there is no tooling? What do we do now? And the answer is, remember, tooling is not the end all. There are practices. Refactoring is a practice more than it is a tool. And there are more refactorings than there are automated refactorings. So get the book. Get the book. If you don't have it, it's marvelous. It completely changed the way I code. I am running out of time. We're about to go into our conclusion, but I just want to say, my name is Jon Reid. If you don't know, I have my blog, Quality Coding. That's my book. I work for Industrial Logic, where our job is to help your teams ship stuff better and faster. So, is this the end of the story? App code is dead, long live Xcode, and you've seen already, it's not. Does Apple own the entire ecosystem and we have no say? No, because that's how it's always been. Here are some marvelous tools that other folks have written. SwiftLint, Swift Format, Toist for module management, oh yeah. Muter for automated mutation testing, to test your tests. Sorcery for metaprogramming. Injection for hot reloading. Periphery for finding dead code, unreachable code. A View Inspector for writing unit tests against Swift UIViews. And forgive me for putting up something I've worked on, approval tests for an easier way than regular assertions. So it's the way it's always been. Let's keep making good stuff and let's find out what's out there. Let's keep an eye on these alternative IDEs. I've shown you VS Code. JetBrains Fleet is their answer to VS Code. It's something they're working on, and their features matrix has a row for Swift, so we can track how they're doing. They're making it public. Takeaways. Oh, I'm at time. I'll wrap up here. One takeaway. Let's craft the tools that we need. And that's easier for things like Swift testing, which is open source. And let's work together to do so. Takeaway number 2, get outside of the Apple ecosystem. Try another language, try another IDE. Especially try anything from JetBrains. You'll be surprised if you've never experienced their tools before. And number 3 is connect with other software crafters outside of the Apple ecosystem. I love getting together with y'all, but there are plenty of other folks with great ideas and great tools and great practices. Here are some places to find these people. The London Software Craftsmanship group is the first and oldest and biggest, I believe. Philly XP has meetings online. Seattle Software Crafters also has meetings online, and there are many more. Just do a search. Socrates, software crafting and testing conferences in a number of countries. The Global Day of Code Retreat, where we all work together on the same day, on the same problem, with the same constraints, and form your own book club. Maybe it's at work, maybe it's outside of work. If you're looking for books on software crafting, I can suggest some. But that is it. Remember that tools are great. They're not the end of the story. Focus on practices. And that's all. Unfortunately, we are out of time. So I think Q&A will happen. We'll take 1 or 2 questions. All right.